everybody. Let's get started. Our team has been busy at work for the last few months, and they're getting ready to the point that they can get their first release of their new application. It's a microservice-based application, and the team has stored it in GitHub as a monorepo. And they're starting to get very excited about the potential release. However, the application keeps growing really quickly. And on the left-hand side here, we have a simple overview of what the application looks like in the backend. We have a front end backed by 5 microservices here in purple, each one connected to their own databases and cache. And additionally, they'll have 4 testing clients that they use on a regular basis. But as the application keeps growing and growing, compiling, testing, and deploying all these different things manually is becoming a problem. Errors are starting to crop up. There's no pipelines to run, which is causing a problem in their work-life balance. So our mission will be to create an automatic pipeline that will help our team get back their work-life balance. And this pipeline should work natively with monorepos, encourage dry principles, and implement GitOps and use containers. But more importantly, we want to do everything as code so that we can recreate the steps as needed. So I'll be your guide in this mission. My name is Juan Peredo. I'm a tech consultant, architect, and developer, and everything in between. And here is what we're planning to do. So we will take the code and we'll push it to GitHub, and then we'll have Screwdriver CD, which is a CI/CD tool, pull the changes from GitHub, build our containers, and push them to Docker Hub. Now we'll be installing Screwdriver in K8 using help, and it's important to set up the correct specs so that you can have the best experience. But enough of that, let's go take a look at the application real quick. So here we have the application running. It's a simple application in the front end, but as I said, it continues to grow. So people can log in, take a look at, for example, some promotions that they're making for people to buy awesome products. We have a search screen and a detail screen, and it's the same thing for everything else. So we can look at our customers, etc., etc. And that's our application in a nutshell. Let me show you what the repo looks like. So we have our root folder. Inside our root folder, we have our different services, like our audit service, our customer service, our promotion service. And we also have our web folder that contains the front end, including a Dockerfile that's in charge of building our application. Additionally, we also have a Screwdriver.yaml file, which is what will be in charge of defining our pipeline for us. And we'll walk through this Screwdriver.yaml in a few minutes. All right, but speaking of Screwdriver, let's take a quick look at it. So here I'm logged into Screwdriver. I can see that we have 2 pipelines defined. This is the one for our particular application, and this is actually a template that we'll be able to use as well. And we'll discuss what a template does and how it does it in a second. If I go into it, we can see the different steps that we've gone through, as well as some metrics about how our application pipeline has been running and how much the average time is. We also have the duration of each individual run. And one thing that I think is really cool is if we go to the bottom and I select a particular step in our job or pipeline, Screwdriver is going to give us a breakdown of everything that is running. And if I look at one of them, in this particular run, that was abnormally long, we can see, and it's a little hard to see, so let me see if I can make this a little bit bigger. And we can see that testing our application in this particular step is taking was taking a whole lot longer than it should have, compared to what it took the last time we ran it. Was over twice as long. And that's really cool when we're trying to figure out how our application pipeline is doing health-wise. And here we can see our Screwdriver, the YAML file in more detail. And this is what defines our pipeline. And there's different steps that are going to run to build our application. So at the very top, we can see that there is a shared section, a global section that's shared by all steps in our pipeline, or jobs as they call them in Screwdriver. Then we have the jobs section here at the bottom. And now let's walk through each one of them individually. So the shared, these are, for example, environment variables that will be shared for each job that runs in our pipeline. Another cool feature of Screwdriver is that you can cache any particular folder or folders. And in this case is the package modules that needs to be so that it doesn't need to be re-downloaded every time we run our pipeline. So this will be stored locally in Kubernetes. And then we have a particular job. And in this case, we have a main job that is going to be using a Golang image because this is a Go-based application. We're going to say that we're going to run this pipeline or this particular job of the pipeline anytime there's a PR or a commit to our GitHub repository, but only if it's hitting the promotion-server directory or the global utils directory. If it's not one of those directories, we're not going to execute this particular job. And then finally, we have the steps. And these steps should be very familiar to anybody that's done Go development before. Now, these are very common steps. And in fact, all these steps could be shared by all the microservices that we're building in Go. And remember, one of our goals with this pipeline is do not repeat yourself. So the fact that we're going to have to repeat all these steps every time we build one of our services is not the best. So what we're going to do is we're going to take those steps and we're going to create a template. Now, a template is a way to abstract some of or extract some of those steps and put them in a place where they're reusable. What does this? Let's walk through this pipeline. This pipeline is actually built on the top by some metadata that will allow us to identify and call our pipeline, and the individual steps that we want to reuse. So let's learn how to use that template. So here, I'm going to have our second pipeline job. So this is a continuation of our original template. But instead of having all those steps there, I'm basically going to use the template. And the way I'm going to use that template is I'm going to have, I'm going to call it by namespace, name, and version. And then I'm going to provide any additional steps that I want to run besides the steps on that template. And these steps will be merged with the steps from our template. And how does that work? Well, basically, we're going to take the steps that we defined in our customer job and the steps we defined in our template, and it's going to put them together. Now, notice that it's put them in a specific order, and that's because of the pre and post portion of the name of the of our additional steps. So anything that was pre, so for example, pre-download is put before the download step. Anything that's post, so for example here, post-test is going to be placed after the test step when it's actually executing the job and creating the pipeline. So awesome. So now we managed not to repeat ourselves. How about building images? So now we're going to add a new job to our pipeline. And this job is actually going to build our front end. And the first thing we're going to notice is that we're going to actually use our Docker image. Then we are going to tell it through an annotation that we want to enable Docker. And what this actually means is that we want Screwdriver to run an additional container within our pod that's going to be building our pipeline, then this particular job. And this additional pod will be running Docker in Docker, so that we'll be able to run Docker to build our image. The other thing that we're going to need here is we're going to need a couple of secrets, so our username and password, so that we can log in into Docker Hub to push our image. And finally, we have the steps to build our front end. So we're going to use typical Docker build, and that's going to use the Docker image we saw a second. That's under the web Zapper folder. Then we're going to have our Docker login, and finally we're going to push that to Docker Hub. All right. And that's our pipeline. So let's take a look at how that went when we run. So here's our pipeline as we had seen before. We can see the 3 steps, the one that's running our promotion service, the customer service, and our web image. Now, if I go into the first one, you can see the different steps. We can see the setup steps. So the setup steps are actually automatically created by Screwdriver. And in particular, I want to show you at this point this one, because it's automatically pulling our code from GitHub into the image so it can build it. So it's something that we don't have to worry about. It automatically happens. Then we notice that it's going through our different stuff. So the download, notice that the download is taking 1 minute and 55 seconds because it has to download everything from the internet the first time around. Then it's going through the different steps, doing some testing, and doing the build of our application. And once it's done, and before it destroys the Golang image that is used to run these steps, it's actually gone down here and it's cached the contents of a folder of our workspace package mod folder. Now, if I go back up and I look at the customer job, I want to show you here in the setup. I'm going to look at the Screwdriver cache bookend, and we can see that one of the first things is done is it's downloaded our cache. And now if I look at the download step, the download step took only 2 seconds because Go is smart enough to detect that all its dependencies are already in that directory and it doesn't download anymore. So the cache has saved us a certain amount of time and bandwidth. All right. And finally, if we look at our web image, we can see that is actually published our image to Docker Hub. Fantastic. So that's how we're going to build everything with a screwdriver. However, we caused additional work for our team because now we have to have Dockerfile for each one of these elements. In fact, we're going to have to maintain 11 Docker files. So instead of using Docker files, we're going to use Buildpacks. And Buildpacks are really cool because it's like using somebody else's Docker file that somebody else has to maintain. And this can be created by a third party or by our IT department, or and then we just have to reuse them. And the way it works is the Buildpacks take a look at our code, they push it to a builder, and this builder has all the steps necessary to build a number of code bases. And this builder will pass the code to the Buildpacks that will analyze the code and determine if they are applicable to that particular code base. So for example, if we had a Node.js application and you had a package.json, then it would run some package.json, I mean, a Node related build. So for this demo, we're going to use Pack, which is a CLI tool maintained by the Cloud Native Buildpack project, but there are multiple implementations of Buildpacks. Now, when we're using Pack, this is what the commands are going to look like. So I'm going to say, Pack, build me an image with this name. Then I can give it additional parameters. So this is the path to where my code lives, and then I'm telling it which builder to use. Now, not all builders are created equal, because the builders only need to attach to certain specs. They can use additional environment variables, and they can produce images that, even though they still work, they're different. So here's an example. So this is building our customer service, but we're going to be using two different builders, and each one of them is using as you can see, a different environment variable. Now, finally, because we don't want to always have to specify all these options every time we invoked Pack, we're going to use a Project.toml file. And what that's going to happen is Pack is going to take a look at our code and our Project.toml file to determine what the correct command to run is. And in this case, if we look at the sample toml file on the right, you can see we have some metadata on the top. Then we have some build commands. So we're indicating which builder is our default builder, so we don't have to specify on every command. We also specifying which files we want to exclude when we're building our application. So you can think about the exclude flag here as a git ignore. And we can also have some build environment variables if we wanted to, as well as some metadata. All right. And the images that Pack and Buildpacks in general are going to create are fully OCI compliant, meaning that you can run in Docker, with Docker, Docker Compose, in Kubernetes, anywhere you can run an image. And Pack can be integrated with any CI/CD tool. And Pack itself needs a Docker daemon to run, but there's other implementations of Buildpacks that don't need them at all. So let's take a look at that real quick. All right, so let me come up here. I'll bring it to my project. We're going to run some commands, and I'll explain what they're doing. So the first command I'm going to run Here, let me start it up and I'll explain as it goes. The first command that we're running is basically going to build our image for our prod user service. And I'm saying a pack build my user service. And this environment variable tells it that actually what I want to build is the binary for the code that's in the user server directory. And I'm telling it to use the paqueto build pack. Now that's going to build a small compact image for me with all the bare minimum that my application needs to run. The other command that I could run, and I won't run just to save a little bit of time, is the top one. It's also built in our user environment, our user service. It has a different environment variable name, but it's actually doing the same thing. It's actually going to build the binary for my user service, but using a different builder. Now that's going to be building for me a dev image, because a dev image will have more information. It will have a curl. It will have other information on it. That will allow me to log into the container if need be. All right, but now we can see that it's actually doing its thing. And if we go back up here, we'll see the first thing that it did was it detected which build packs to use. So it's going to install some certificates, it's going to download our dependencies, and it's going to build our application. Then it's actually going to start the process of building. So downloaded the build pack certificate, building the Go mod, and building the actual application now. And that's going to take a few more seconds. So I've run these commands before. So let me show you what the difference is between the two images, just based on which build pack I used. I'm going to come up here. I'll put that there, but we're actually going to wait for this to finish. The other thing I'll mention is that because I have a tom.file in my project file, my project directory, I can see the project.tom, the command that I run, so build pack on this command that I run over here with this particular builder, is synonymous with this one over here, without me having to specify the builder, because our project.toml file has defined in there that that's the builder that I want to use. Plus, it has a whole bunch of other folders that I don't need to include when I'm building my image, and some metadata that I could, if I wanted to, use in my pipeline or just for information. Well, that's pretty cool. And now it's done. I'll come up here, and I'm going to show me the images that we just built. We can see the first one is 167 megs for our dev image, and while our prod image is 72. It's much smaller. And that's the power of build packs. You can build images for a specific purpose just by changing the builder that you're using or the build pack that you're using. The key takeaways of what we just discussed, right? So we've done everything as code, so it's repeatable. We use Screwdriver to automate all of it, from pulling the code based on a particular PR or commit or a particular folder that has changed. We've simplified the process of building our application, including the use of build packs, so we don't have to maintain additional files. We use it with technology that's meant to be scalable. And all that results in productivity and cost reductions for our company. But more importantly, that allows us to regain our work-life balance. And with that, come to an end of our presentation. Any questions? And thanks to the CCon and all the conference sponsors. All right, everybody. Thank you for coming to the session. If you have any questions, please don't hesitate to put them on the Q&A or the chat windows. What are the differences between Screwdriver, Jenkins, and Tekton? So many choices. Well, it really is up to what you're trying to achieve, right? So, for example, one of the main differences between Screwdriver and Jenkins is the fact that Screwdriver supports monorepos out of the box, right? We saw on the demo how I could tell Screwdriver to execute a particular job based on a particular, based on where the change that was committed went. So if it was committed to a particular folder, then we would execute job A. If it was committed to a different folder, we could execute job B, or both if we wanted to. At the end of the day, it depends on what you're trying to achieve. Another really cool thing that I really like from Screwdriver is the fact that you have reusable pipelines, which is what we saw in the demo as well, where steps that are repeated across multiple pipelines, and not necessarily just the pipeline you're working on, but it could be pipelines that somebody else is building, is that you can take those pieces and put them into a template and you reuse that template all the time. Yes, reusable templates, sorry. Thank you, Alan. I appreciate the correction there. Yes. Any other questions? Also, you emphasize a lot of Screwdriver. Would it make sense to make it be shareable or marketplace for all its users to share and contribute? Yeah, a lot of those templates, Screwdriver has a section where you can publish those the templates, and therefore you can share with different people. So yeah, absolutely, it should. It's something that's out there, and it's something that makes Screwdriver more shareable and community driven. Speaking of which, if you go to their website and you can see all the information, and additionally they have a Slack channel that you can join, where they're very responsive and they really appreciate contributions. All right. Anything else? No. All right. Well, thank you, everybody. I really appreciate you guys coming and enjoy the rest of the conference. Bye.